Dear students, in this video, I will show you how to prove the Lami's theorem. First, uh, you have to write the Lami's theorem. Then you have to write the expression. So it will be basically, say, first draw the diagrams. That means after writing the theorem, show the diagram, and you will write here according to the diagram A by sine alpha is equal to B by sine beta is equal to C by sine gamma. Next, what is A? A is basically this is A, that is magnitude of the vector A. B is magnitude of vector B, and C is basically magnitude of vector C. Okay. Now here what we have to write, that for a plane when three forces are in equilibrium, they are concurrent and they will form a closed triangle. So that you have to write. That means three concurrent forces are in equilibrium will form a closed triangle. So you will show the diverging vectors like this. These are forces or vectors, right? Means they will be basically forces. So for equilibrium, so this is A, this is B, and this is C. Now you will show the triangle also, because they will form a triangle. So it is always best that you show it like this. That means, so A, draw it parallelly. So A will be this. That means the length is same as this length. Then B, parallelly shift it, and then C, parallelly shift it. Maintain the lengths. Surely they will form a closed triangle. Although during examination you need not means measure and show. Simply show, means by eye estimation you just show it. Okay. So it will be enough. For your understanding, I am telling that this length is equal to this length is equal to this length, and this length is equal to this length. Now here you see that the angle between the angle alpha is opposite to A. So this is alpha, or you can name this as A also, capital A. So this is vector A and the angle is alpha or capital A. Then opposite to vector B, it is beta or capital B, and then opposite to vector C, the angle is gamma or capital C. Next, if I draw those angles here also, then what is alpha? You see that alpha is the angle between vector C and B, or B and C. So this is the angle. Therefore, where is C? C is this one and B is this one. That means from this point, if I, that means redraw B, then alpha is this angle between B and C, not this angle. This will be therefore pi minus alpha, because this is alpha and total angle is pi, so it will be pi minus alpha. That should be understood properly, because if I see that when alpha is considered, from this point both the vectors are outgoing. So at this point C is outgoing, therefore if I draw B here, then B will also be outgoing, therefore that will be the angle alpha. and this angle is pi minus alpha. That you have to understand. So similarly for all angles it is the case. Therefore you see that what is the angle beta? Beta is angle between A and C. So at this point A is outgoing but C is incoming. Therefore if I draw, that means both the forces either outgoing or incoming, then this will be the angle beta. Or you can show it this way also. That means if you go for outgoing vector, then also it will be that angle beta. That means at this point. Okay. Next is angle gamma. So what is the angle? Angle between A and B. So you see that at this point A, if I draw this way and then B this way, then it is gamma, and therefore this is pi minus gamma. So pi minus alpha, pi minus beta, pi minus gamma are the internal angles for the triangle. Okay, now what you do after that, this is the statement that you have. That means after writing the statement you write this. Then what you do, you draw a vector, like draw a perpendicular from this point on this line. Okay, so this is perpendicular from one vertex to the other, the opposite base. So this, what is the length of this? Length is equal to sine of this angle. Again the same length is equal to sine of this angle. Therefore can we write that it is this length, say for example this is say x. If it is x, then x, can I write that x is equal to sine of pi minus alpha and this is same as sine of pi minus gamma, because this length is common to this side and this side. Therefore this length is equal to pi minus alpha and pi minus gamma. I'm sorry, it will be a sine alpha. I'm sorry, it will be a, let me write it, a sine pi minus alpha. This is no sorry, c, this is c sine pi minus alpha, extremely sorry. C sine pi minus alpha, and this is magnitude of C, and then a sine pi minus this is pi minus alpha, C sine pi minus alpha, and a sine pi minus gamma. This is pi minus gamma. So this is pi minus gamma. Therefore we can write that a sine pi minus gamma is equal to C sine pi minus alpha. Therefore we can write that a by sine, now sine pi minus alpha is same as sine alpha, alpha is equal to C by sine gamma, because pi minus gamma is sine of pi minus gamma is sine gamma. In the same way you can show for the other. That means if I draw perpendicular from this, perpendicular from say this one on this line, then this same length, that length, that is perpendicular, the length of the perpendicular is equal to sine of this. That means A sine of this, what is the angle? Pi minus beta, and the same length is equal to B sine pi minus alpha. Therefore, this length, if I consider this length as y, then I can write that y is equal to this length y is equal to a sine of pi minus beta, and this is same as b sine of pi minus alpha. Okay, therefore we can write from this that a sine beta is equal to b sine alpha. Therefore we can write that a by sine alpha is equal to b by sine beta. So this is one equation, and this is another equation. So from this, a by sine alpha is equal to c by sine gamma, and this is a by sine alpha is equal to b by sine beta. Therefore combining these two, you can write that a by sine alpha is equal to b by sine beta is equal to c by sine gamma. So if you combine these two, then this is same as this and this is same as this, therefore these three are equal. That means these there these three are basically same, so you can write this. So that will complete the proof. Okay, thank you. Another thing is that you can show this in the converging mode also, that means all the forces are incoming, so that way also you can show it. Okay, so either you show converging, diverging or converging, no problem, but after that you show the triangle, and from the triangle you draw the perpendicular, and then you can show the means length in terms of sine of the sides of the triangle. Okay, I guess it is clear. Thank you.